Okay, so we have learned about combustion reactions of alkenes, how it form energy, so it can produce as fuel, but it also formed pollutants, yeah, because of combustion reactions gives pollutants and how to remove it. Okay, so we are done with the first reactions of alkenes with its combustion. The second famous reactions of alkenes is free radical substitution, yeah, known as halogenations. Why it is called as free radicals? Since the substitution reactions only occur in the presence of UV light. Okay, and according to our previous video, I already told you that the homolytic fission will occur in the presence of UV light and form of free radicals. Okay, this is the step-by-steps of how methane undergo free radical substitution to form chloromethane, yeah, and HCl as the other products. Okay, CS4 plus Cl2 becomes CS3Cl plus ACl. So we will learn about the step-by-step how the free radical substitution occurs. This is consists three steps, yeah. The first one called as initiation. Initiation. So this is how the free radical form. Okay, once again, initiation is the step of how the free radical form. The Cl2 will undergo the homolytic fission, as you know, like this, yeah. Okay, to form two free radicals. Yeah, since it has an unpaired electron. Okay, you can see that two free radicals will be produced. This is the first step. Okay, what happened after we have the free radicals? The free radicals, as you know, is a very reactive species. Yeah, even it is neutral. Yeah, but it is very reactive since it has an unpaired electron. It will try to find yeah its pose. Yeah. So how to get one more electron is by propagation reaction. Okay, this is the second step of free radical substitution. Propagate, that means increase the chain, yeah. Propagation, increase the chain. Propagation, use and produce free radical. Use and produce free radicals. How to do this? You know that at the beginning we have CS4 molecule. Okay, you can see here CS4 molecule. And then at the initiation step, you know that Cl radical present, right? Okay, it try to find another electron, so it will attack one hydrogen from the natural CS4. So the second homolytic fission will be occur. Okay, and then this will create the CS3 free radical with H free radical, right? H free radical combined with the Cl free radical to form covalent bond. Okay, so that's why HCl produced here. And then the new free radical also produced. This is the first step of propagation. Okay, understand? Okay, because CS3 is also the free radical, it will try to find another electron as well. Okay, so it will try to attack another chlorine atom. Yeah, that still neutral. So CS3 free radical try to attack the Cl2. So the homolytic fission occur again, yeah, to form the Cl radical with Cl radical. The Cl radical combined with CS3 to form covalent bond. So now this Cl free radical neutral, yeah, because already combined, yeah, find it pair. So to form the product CS3Cl, yeah, you know that this is our product. Look here. So the product formed in the second step. This is the propagation step. Don't forget the Cl free radical also produced in the second step, in the second propagation step. Okay, so this will be you know that this will react again and again, you know, because the Cl at the first step. Yeah, is the first step. Appear again at the second step. Yeah, so this is like a catalyst, right? So this will be occur again, again, and again. Until what? Until all hydrogens in methane has been substituted by Cl. So let's say the Cl free radical will again attack the CH3Cl since it still has CH3 to form CH2Cl radical. Oh, okay. Look here. This is not a good representation of a free radical since, look here, you can see that the dot is supposed not at the Cl, right? But instead of here, the dot should be on C. Yeah, because you know that when Cl, you can focus on the third, yeah, the third step. When the Cl free radical attack the CH3Cl, homolytic occur again. Okay, this produce Cl radical, okay, with CS2Cl radical. Yeah, the radical will be occur on C and not on Cl. So that's why this is wrong. Yeah, should be the dot should be on C. Okay, and then the CS2Cl free radical can combine with another Cl2 to form the product, the di substitution. Yeah, CS2Cl2 with Cl. So once again, this is called as reaction since it can occur again, again, and again. Okay, so I hope you can understand about this. Okay, you can try to understand and memorize this. Okay, so once again, Cl2 free radical as the Cl free radical will attack the methane to form CH3 free radical, and then the CH3 free radical combine with Cl2, another Cl2 to form product and another Cl radical. Okay, so this can be occur again, again, and again until all all hydrogen on in methane replaced by Cl. So the final product is CCl4. Yeah. So it can produce CS3Cl, CS2Cl2, CS3Cl3, and then the last one CCl4. Okay. But once again, this can be occur if, yeah, if Cl2 very, very in excess and high intensity of UV light, then CCl4 will be formed. Okay, since once again this is like a cycle, yeah, the reaction will be occur again and again and again. So how the free radical substitutions finish? Okay, it is when the termination reactions occur. Okay, this is the third step, the last step of the free radical substitution. This is the third step. Termination occur when the free radical met free radical. Okay, you can see that in halogenations of methane, you can see that there are two types of free radical that produce, which is the Cl free radical and CH3 free radical, right? The first substitution. So when Cl, so what's the combination that can be occur during the termination process? Cl can combine with another Cl, CH3 can combine with another CH3 to form ethene, or CH3 combine with the Cl free radical to form this. Okay, but how if we have CH2Cl free radical as well? So the combinations will be increases. Okay, understand? Okay, the interesting here is if methane, yeah, if halogenation reactions occur in methane, this is simple since all four hydrogens at the same environment, right? All hydrogen attached directly to the C. But how if we have ethene? The hydrogens, all hydrogens also at the same environment, right? So no problem. But how about if we have propene? The second hydrogen here is at different environment with the first and the third. So there are two possibilities of free radical form. Yeah, the first one, well, when the hydrogen attracted by the chlorine, yeah, is at the first hydrogen, so it can change to S2C, CS2, CS3, free radical. But when the pink one, yeah, the second environment hydrogens attack, this will form this, the isopropyl free radical, right? So you can see there are two types of free radical will be produced here. Why? Because there are two different environments of hydrogen. So if the types of free radicals will be increases if the environment of hydrogen increases. Okay, I think that's all about free radical. Is it clear? Okay, I hope, yeah. Because alkane can undergo substitution reaction with halogens, we can see that the bromine, yeah, the bromine water can undergo decolorization reaction and the decolorization in the presence of UV light. Yeah, in dark, the substitution will not occur. So bromine water still brown. Yeah, will not occur. But in UV light, the free radical substitution of FRS occur. So the bromine will decolorize. Okay, let's practice. What's the answer? The answer is D. Why D? Because this is a termination. Sorry, not D. Termination D. Yeah. Okay. The step D is require very high energy actually. So B is the lowest activation energy. Since it is a termination process, yeah, just combine and release energy. Yeah, it should release energy actually. So lowest activation energy. How about this? Okay, how many different structures of X free radical are possible? Okay, you can see that I already explained that the types of free radical depends on the types of hydrogen environments. Okay, now let's count the hydrogen environments. You can see that this is CS3, CS3, CS3 connected to C, so identical, right? So this is one environment. This is the second, and this is the third. Okay, so for example, I will use different color here, and this is the third. So for example, the chlorine free radical attack the orange hydrogen. So what's the product? CS3, CS2, C, CS3, CH2, CS3. Okay, this is the first free radical that possible to form. Okay, and then how about if Cl attack the hydrogen at the pink condition? This will produce CH free radical here. CS3, CS3, CS3. Right? One more. The green condition. CS2 free radical. CS2, C, CS3, CS3, CS3. So once again, since it has three different hydrogen environments, so three possibility of X free radical will be formed. Okay, please try this. Methane and chlorine involve initiation, propagation, termination. What involved in initiation stage? Initiation stage, once again, Cl, homolytic fission, yeah? So should not heterolytic, so this is wrong. So between C or D, but there is no Cl free radical here, right? Okay, so this is initiation condition, Cl free radical. Don't forget we have propagation step, CS4 plus Cl2 plus Cl free radical to form CS3 free radical and HCl, right? So you can see that in propagation step, CS3 free radical form. There will be no possibility of its free radical form, yeah, during the initiation or propagation step, since the hydrogen free radical directly combine with Cl free radical to form HCl. Yeah, so will not its free radical, but CS3 free radical. D is the correct answer. Okay, this is the question took from paper 2. Please try to do this. Okay, what is free radical? It is a species with unpaired electron. Okay. Name and explain the type of bond breaking which occurs to form chlorine free radicals. Homolytic fission. 2 points here. So you should explain, name, and explain how homolytic fission occurs. One electron goes to each chlorine atom. Yeah, or pair of electron is shared equally between two atoms. Yeah. Okay, you should explain like this. Name the stage of the reaction mechanism which occurs when a methane molecule reacts with a chlorine free radical. Name the stage. Okay, let's discuss. What the stage? It is propagation, yeah. Okay, when methane react with chlorine free radical. This is at propagation step. Complete the equation then. So, homolytic fission to form CS3 free radical and HCl. Yeah. Okay, this is the last question about alkene. During the bromination of methane, the free radical CS3 is generated. A possible terminating step on this reaction is the formation of ethene by the combinations of two free radicals. What could be produced in a terminating step during the brominations of propane? Okay, please try. Okay, let's discuss. You know that propane has two different hydrogen environments, right? Here and here. So there are two possible free radicals that could form. Okay, so what is the product of terminating step? So let's say this is the first free radical, this is the second one, yeah. Let's say first combine with the first. So produce CCC, CCC, right? Here, yeah. The free radical combined with the first free radical as well. So we'll produce 1, 2, 3, 4, 5, 6. Yeah, hexane. How about first and second? Okay, this combined together. What the product then? CCC, free radical here, and then the another free radical CCC, like this, right? Okay, so make bonds here. 2-methyl pentane, yeah, 2-methyl pentane. Okay, you can see that number 1 is 2-methyl pentane. So this is correct. Okay, what's the other possibility? The second free radical combined with the second one, right? Second with second. So how to make the combination? This with this, right? Make a new bond. So 1, 2, 2, 3. I mean 2, 3 dimethyl butane will be formed, right? 2, 3. You can see that this is 2, 3. 2, 3 dimethyl butane. What is this? 1, 2, 3, 4, 5. 1, 2, 3. Is it possible to produce this? Okay, this is impossible, yeah, because we already see that the possibility only 1 and 1, 1 and 2, or 2 and 2. Okay, and then you can see that they will not produce compound number 3. Okay, so the correct answer for this is B. 1 and 2 are correct.